The universe is expanding. Every galaxy is moving away from every other galaxy. Space itself is stretching in every direction, and it has been doing so since the very beginning of creation. That much is established, confirmed, measured with extraordinary precision. But the question that keeps cosmologists awake at night is not whether the universe is expanding. It is what it is expanding into, and why it may be about to stop.
To understand the problem, you first need to understand what expansion actually means. The universe is not expanding into empty space the way a balloon expands into a room. Space itself is stretching. The galaxies are not moving through space. Space is growing between them. And the light traveling from distant galaxies to our telescopes gets stretched along with space, arriving redder and weaker than when it left, which is how we measure the expansion in the first place. So when we ask what the universe is expanding into, the honest answer is that the question may not have a meaningful answer in the way we intuitively expect, because there is no outside, no pre-existing container that space is filling up. Space is the container, and it is making more of itself. But here is where it gets genuinely strange, because for the last 20 years, cosmologists believed they had the next chapter of the story figured out. In 1998, two independent teams discovered that the expansion of the universe was not slowing down as gravity would predict. It was accelerating. Something was pushing space apart faster and faster, something they named dark energy. And the standard model of cosmology incorporated it as a fixed constant, a permanent feature of the universe, driving an eternal and ever-accelerating expansion with no end. That picture is now falling apart. In November 2025, a study published in one of the world's leading astronomy journals found no convincing evidence that the universe is still accelerating. The expansion is continuing, but the push behind it may be weakening. Dark energy losing its strength over cosmic time rather than remaining constant as the model assumed. And if that is true, it changes everything we thought we knew about how the universe will end. Then, in early 2026, came something even more unsettling. New data from major dark energy observatories led one physicist to conclude that the cosmological constant, the number Einstein introduced over a century ago to describe the energy of empty space, may actually be negative, not positive as assumed for the last 2 decades. And if it is negative, the universe does not expand forever. It expands for approximately another 11 billion years, reaches its maximum size, and then reverses, collapsing back inward, everything in existence falling toward everything else, ending in what physicists call a big crunch, a single point of infinite density that mirrors the beginning of creation. For 20 years, the standard answer was that the universe expands forever, accelerating into a cold, dark eternity, where eventually all stars burn out, all black holes evaporate, and nothing remains but empty, expanding space. That answer is now being seriously questioned by multiple independent lines of evidence, and the alternative, a universe that ends by collapsing back on itself, is no longer a fringe idea. It is what the newest data is pointing toward. And then there is the deeper question underneath all of this, the one that the expansion raises but cannot answer. Space is stretching, but into what? If the universe is everything that exists, then there is no outside by definition, and the question has no answer. But if the observable universe, the 46 billion light-year bubble we can see, is only part of a larger structure, then what lies beyond our horizon? What space is expanding into? What existed before the expansion began? Remains entirely unknown, entirely outside the reach of any telescope or equation we currently possess. The universe is not only expanding, it is expanding in ways our models did not predict, driven by a force we cannot identify, possibly heading toward an end nobody anticipated, into a space that may not exist in any meaningful sense. And the more precisely we measure it, the stranger it becomes. Subscribe, because next time we are covering the Big Crunch in detail, what it would actually look like, how long it would take,
and what physics says happens at the very end of everything.